The second section here for chapter 4 is rather quick. In fact, the whole first page of the notes is just going to list out the theorems and the corollaries for some of the divisibility rules. We're going to consider divisibility by 2, 3, 4, 5, 6, 8, 9, and 10. I will let you read through those at your leisure. On the second page, I do have a summary of the different divisibility tests. So I'm going to use this summary because really the summary is all you need to know to test for divisibility. And we're going to go through a couple examples. So the first example, and you'll see me go back and forth with the table above here. The first example, we're going to go through the numbers in this table and decide if they are divisible by 2, 3, 4, and so on. Divisibility by 2, 5, and 10 are the easiest. For a number to be divisible by 2, it has to end in an even number. So if the ones digit is even, so 0, 2, 4, 6, or 8, it's divisible by 2. So 1,950 ends in 0, it's divisible by 2. Oops, and that works so much better when my pen is turned on. There we go. 2014, ones digit is a 4, that's even, so it's divisible by 2. 2015, the ones digit is odd, not divisible by 2. And then 51,120 ends in a 0, that's even, divisible by 2. That easy. For fives, if the ones digit is a 0 or a 5, it's divisible by 5. So 1,950 is divisible by 5, but 2014 is not. And the last two, 2015 and 51,120, are also divisible by 5. For divisibility by 10, the last digit has to be a 0. It's that simple. So 1950 and 51,120 are both divisible by 10. The other two are not. So now let's go back and fill in a little bit more. The 3. If the sum of the digits is divisible by 3, the entire number is divisible by 3. So if we consider 1,950, 1 plus 9 plus 5 plus 0. If you add those together, you end up with 15. 15 is divisible by 3, so 1,950 is divisible by 3. So moving to the 2014, 2 plus 0 plus 1 plus 4, those add to 7. Since 7 is not divisible by 3, neither is 2014. 2015, add these together, you're going to end up with an 8. 8 is not divisible by 3, so neither is 2015. And then lastly, 51,120, 5 plus 1 plus 1 plus 2 plus 0, so that's 5, 6, 7, 8, 9. That is divisible by 3. I'm going to jump to the divisibility by 6. For a number to be divisible by 6, it needs to be divisible by both 2 and 3. Since 1,950 is divisible by both 2 and 3, so is 6. In the case of 2014, it's divisible by 2 but not 3, so therefore it's not divisible by 6. 2015 is divisible by neither 2 nor 3, so it's not going to be divisible by 6. 51,120 is divisible by both 2 and 3, so it is also divisible by 6. So we only have 3 more columns to go. Divisibility by 4 and divisibility by 8, they take divisibility by 2 and basically step it up a notch. To be divisible by 4, the second 2 digits must be divisible by 4. So in the case of 1,950, you want to check, is 50 divisible by 4 or evenly divisible? It's not. You're going to have a remainder there. So that means 1,950 is not divisible by 4. 2014, you're going to check the 14. 14 is also not divisible by 4. 2015, you've got a couple options here. To be divisible by 4, the number first must be divisible by 2. Since 2015 is not divisible by 2, I don't even need to bother checking it for 4. But 15 is not divisible by 4. And then our last one, 51,120. You're going to take the 20, divide it by 4. It does go evenly, so that is divisible by 4. For divisibility by 8, you're checking now the last 3 digits. They must be divisible by 8. In this case, if a number is not divisible by 4, you actually don't even need to bother checking it for 8, because if it's not divisible by 4, it's not going to be divisible by 8. So the first 3, we actually don't even need to check. But if you wanted to test them, you could do this on a calculator. If you take 950, divide it by 8, you'll see it doesn't go in evenly. 14 and 15 are a little easier to check in your head. The last one, 120, divide that by 8, it does go in evenly. So 51,120 is divisible by 8. That leaves just one column. Divisibility by 9 is actually very similar to divisibility by 3. In this case, you're going to add up the digits and check if they are divisible by 9. So in the first instance, we have 1,950. 1 plus 9 plus 5 plus 0, that's 15. 15 is not divisible by 9. The next 2 are not divisible by 3, so they're not going to be divisible by 9 either. But you can just quickly check. For 2014, they sum to 7, which is not divisible by 9. 2015, they sum to 8. In the last instance, we have 5 plus 1 plus 1 plus 2 plus 0. That equals 9. 9 is divisible by itself. So we have that.